Our next speaker is Jack Schmitt.
Okay, the first title slide, let me just, the reason I say near South Pole or qualify the sampling is that I have a strong suspicion that ultimately the first Artemis landing will not be at the place that we all talk about. I think Apollo had three major precursors instead of Mercury, in addition to Mercury and Gemini. Artemis is in many ways more complex than Apollo system in a lot of ways. So be prepared that the landing may actually be somewhat more, someplace more simple than the one that we tend to talk about at the edge of a crater. Next slide, please. We've already touched base on this to some degree, particularly with Clive, but the South Pole Aitken ejecta, I think, is the highest priority sampling. Boulders at the base of crater or massif walls, as we found at Apollo 17, are very valuable and should be major targets. Radial and a radial sequence, if possible, if you have the rover capability towards SPA center, certainly would be an important part of a plan. Average regolith is several meters down for comparison with Apollo low latitude volatiles. From a future resource point of view, I think this is a very important comparison to make in order to do some cost trade-offs for various resources. A deep core a la 7001-9, I think very important. Solar history comparison with the Apollo deep cores. As some of you know, I've been working on the deep core from Apollo 17 and think that we've identified a correlation between solar activity and the Cambrian explosion. And that needs to be pursued wherever we can pursue it. Gene Shoemaker always said the regolith was a record of the history of the sun, and we've got to remember that. Comparison of ejecta units with low latitude units as one aspect of my studies of the deep core Apollo 17 is that the regolith is primarily made up of ejecta units from other craters. The permanent shadow cryo samples are available, probably available in smaller craters without going into a deep crater. And certainly those cryo samples are going to be very, very important, as people have already said. Next slide, please. And a sample mix, of course, that's going to depend on crew judgment, the training and planning that goes into the pre-mission activities. We need a lot of rock variety, as Apollo has given us. We learn from that variety all the time. And as many units in large boulders as possible. Large boulders, as we find from other missions, have a lot of subunits within them, and they need to be sampled. Also, let me put in my usual plea to allocate entire samples for investigation by consortia. You learn a lot more from a large rock than you're going to learn from a small aliquot. Rake samples with 1 kilogram regolith at each station certainly should be done. Those have been very, very valuable. 76535 was out of a rake sample, and I'm sure we'll find many more. At least one deep core, and coring should be automated. You really got to work on automating coring. I know Honeybee has been working that problem, and this is not an advertisement for them. Whoever can do automated deep core recovery is very important. Deep core, cryo core, and permanent shadow. I will go into this again, but I think absolutely sealed. You've got to come up with a better sealing system than we had for Apollo. I think thermal preservation is secondary. You've just got to keep everything that you cored in the core itself. And drive tube cores, of course, are very important for targets of opportunity, like we found at Shorty Crater and a couple other places. Next slide. The field, among these other things that Brad Jolliffe asked me to cover were field analytical methods. I do not feel that they're as important as documented sampling time unless you get to extended mission times in a lot of EVAs. But if you have them, they need to be a very rapid readout. Most of us field geologists know what an acid bottle gives you almost instantaneous information about whether you're looking at limestone, dolomite, or nothing or something else. Deployable. These systems should be deployable on boulder surface with a HUD readout. That's a helmet readout. I don't know whether the XMU, EMU work is looking at providing voice-activated HUD systems, but there's certainly that is a well-developed technology in military circles, and we certainly ought to be looking at it for lunar EVAs. If you can't get a HUD readout, then it should go to MCC for a readout there. But be very, very careful how you use that information to interrupt what's going on the surface. If you go through the Apollo transcripts, you'll see that interruptions sometimes cause some significant loss of observational information. Handheld, in quotes, means that some other tool is not handheld. Just keep that in mind. And that goes for any kind of carrier or anything else other than a rover that you might have. If you've got it in your hand, you're not carrying something else. Data will be valuable for planning between EVAs, and that's why I think your analytical work probably ought to be something that you don't use so much in real time, but in planning between EVAs. This is an extremely important Mars forward experience to have and to work on. Continued analysis of core cuttings is, I think, something very important, particularly if you have automated those coring activity, and particularly for any released volatiles. And just remember, time is relentless. Dick Gordon made that very clear when I was training for Apollo 15, and it certainly became very, very clear in my experiences on Apollo 17. Next slide, please. And again, I go back to cryo curation. Perfect seals are of greater value than thermal preservation in my mind. And time and mass required to preserve in situ thermal environment may actually make it very, very difficult to do this. It's probably easier to just come up with a perfect seal than to come up with a way to preserve things thermally. Let me add, how much time do I have left?
You have about 2 minutes left.
Okay, there were two really interesting science gems, one yesterday and one just a little while ago. The correlation of hydrogen with pre-Copernican units, that's, I think, something we all need to think about in terms of what is the origin of the hydrogen. It sort of makes it look like it's ancient hydrogen. And the organic correlation with...
slides?
What's that?
Should we advance the slide?
No.
No, I guess.
Yeah, that was the last slide.
Okay.
Yeah, I'm just reminiscing on some other things that we've had. Or organic correlation with maturity index, I think, is a very important observation, and we should look at that as well. From a standpoint of sampling, Brad and others, keep dust out of tool connections. We've got to figure out how to do that. By the end of the third EVA in Apollo 17, the tool connections were just not working, and it was because of dust penetration. And remember to keep it for the first mission or two, keep everything as simple as you can in order to get a maximum return. And finally, to comment on the EMU dust issue, you've got to have self-cleaning EMU surfaces as early in Artemis as you possibly can. Dust, the suit is the primary vector of dust, and the current plan is to have us dusting again with brushes and the like, and that is just, I think, unacceptable after 50 years from Apollo. With that, if there are any questions, I'd be happy to try to answer them.
Thank you, Jack. That was awesome, and we really appreciate the you taking the time today and the extra thoughts you had there at the end. We do have just a couple seconds. If there's a question, go ahead and type it into the Q&A.
I won't be able to see it. I haven't been able to break through.
So we did have one question from Gerardo Dominguez. Has anybody considered thermal fraction collection into perfect seals, that is, collect gases as they come off versus in situ sealed containers? This would preserve isotopic integrity of evolved gases and eliminate maybe some of the need for the rest of it got cut off, but that is a good point.
That is a great question that should be looked at, and maybe, and I wouldn't be surprised if somebody isn't doing that, but it's far beyond my area of expertise.
Understood. Okay. All right, so we're at time. So thank you again, Jack.